and welcome to my channel. So my name is Nienke de Glas, I'm a clinical epidemiologist, and in this video I will teach you what observational studies are. So I will explain you the main relevance of observational studies, and I will discuss the most frequently used observational study designs. So let's get started. So in clinical studies, we are used to great levels of evidence due to this evidence pyramid. And as you can see, cohort studies or observational studies that we are discussing here are somewhere in the middle. They are the yellow bar in this line. And this is due to an important limitation that I will immediately mention of observational data. And this is the problem of confounding. I did a more extensive video on this topic, but basically confounders are factors that disturb the things that you want to measure. So let's say you want to study the impact of smoking on mortality. In observational data, smokers are often very different from non-smokers because they have many other factors that might also be associated with mortality. So for example, smokers might be more likely to also have unfavorable dietary habits or have an unfavorable socioeconomic status. And these are all confounders that can disturb the association that you would like to study. So therefore, the ideal situation of studying determinants and outcomes is to perform an experiment. So in an experiment, you let chance determine which people in your experiment do have a determinant, let's say a medicine or a treatment, and it determines also which people are in the group that do not have a determinant, for example, who receive a placebo. And in an experiment, you would then compare the outcome of interest between the two groups, let's say mortality. Here you get almost completely rid of the problem of confounding because chance has determined the distribution of confounders in the two groups. However, there are some important limitations of experiments. So first of all, they can be very expensive to develop and to perform. They can be complex and take a lot of time, and often a longer period of follow-up time is required. And in many cases, they are also unethical, especially in non-treatment studies. So the example I just mentioned of studying the outcome of smokers is obviously unethical. We cannot randomize people to start smoking. So in reality, intervention studies are quite rare, but observational data can provide a valid alternative, provided that you take confounders, as I just mentioned, into account. So observational study designs can be classified in different ways. So first of all, the timing of your data collection is important. So in the ideal setting, I would always recommend to perform a prospective study. And this means that you start including patients from today onward and you follow them over a certain period of time. So this has as a main advantage that you have a large control over the quality of the data that you're gathering. So you can define which data you want to know exactly, and also you can, for example, ask patients to fill in questionnaires or to perform physical measurements. However, this is not always doable, especially if you need a long period of follow-up, because then your study can take for years and this is not always feasible. So in those cases, a retrospective study is a good alternative. And in this study design, you go back in the data that are already out there. So for example, medical charts. And this allows you often to include a much larger sample size, to include many patients over the past few years. You immediately have your follow-up, because if you start including patients from 10 years ago, you already have 10 years follow-up at the day that you're starting. However, you are very dependent on the quality of the data that you can find. So if certain information is simply not registered in medical charts, you can obviously not include it in your study. And also you are not able to perform, for example, questionnaire research or things like that. Second of all, the number of time points is important. So let's say that you are interested in comparing the smoking habits between men and women. You could simply perform a cross-sectional study where you are looking at one time point how many men and how many women in a certain population smoke. However, if you would like to study the outcome of these people, let's say mortality, obviously you need to follow them over a certain period of time. And that would require a longitudinal study design where you have certain time points or maybe even an inclusion period of many years. And then finally, you need to choose between performing a cohort study, which is the most commonly performed observational study, or a case control study. And I will explain these two concepts in a little bit more detail. So in a cohort study, you include the whole population and you look within your population how many people have the determinant that you want to study, so let's say smoking, and you have a control group of people who do not have the determinant. Then you look at the outcome of interest. So let's say in a longitudinal design, we want to study mortality, and you compare the outcomes. Of course, you do need to think about confounding, but that's not really the point I want to make here. However, let's imagine a situation where the outcome that you're studying is very rare. So let's say that hypothetically smokers do have an increased chance of mortality, but the occurrence of this event is very low in your population. In that case, you would need hundreds or maybe even thousands of subjects to be included in your study, and also you would need to follow them for an extremely long period of time because the event is so rare. And this is often not feasible. So in situations where the outcome that you're studying is very rare, it's also possible to perform a case control study. And this actually starts with the outcome of interest. So this means that you include a group of patients who have the outcomes that you want to study. So let's say that they died. And then you take a random group of people who did not die. And then you go back and look at the distribution of the determinant that you want to study. So let's say we look at the number of smokers in the people who died, and we look at the number of smokers in the people who did not die. And then we compare the two. And we can still calculate a relative risk of the smoking as a determinant for the outcome. However, an important limitation here is that it is not possible to say anything about the prevalence of the determinant. So this means that it's not possible to say in this population how many people actually smoked. And this is because we did not include the whole population, but we only picked out a certain group of people who died and a certain random control group of people who did not die. So this is a limitation of case control studies, but still it can be a very good alternative if your outcome is quite rare. So there you go, I've given you an overview of different study designs in observational studies. So I really hope this was helpful. Please feel free to leave any comments or questions down below in the comment box, and I look forward to see you next time.